in for it. So now we're going to talk about the aging brain. And this talk, just so you know, is a distillation or compilation of 4 separate talks in an all-day seminar on the aging brain. And those 4 talks on an all-day seminar we're not going to get. You're going to get little pieces of all 4 talks. Okay? And there's a new book, I'll show you a flyer on at the end. There's a new book coming out next June from Baker Books called The Aging Brain, Proven Steps to Prevent Dementia and Sharpen Your Mind. And so that's actually already on Amazon for pre-order if people want it. I was surprised to see that. I don't think it's on our website yet. Maybe it is. I don't know if Dean put it up there or not. He might have. I haven't been really promoting that on our website yet, but because it won't be out until June. But anyway, this talk is taken from a lot of information out of that book. So, what is aging? Is it chronologically growing older? That's not aging. God is ancient, but he's not elderly. I would say Enoch and Elijah the same way. When we talk about aging, we're actually talking about functionally growing older, which is a slow decline in vitality and ability. That's what we actually mean by aging, isn't it? Yeah. So, illness and aging, the illness of aging is a new problem for humanity. Before 1900, only 39% of men and 43% of women reached age 65. In 1997, 77% of men and 86% of women lived to be 65. Prior to modern antibiotics and sanitation, life expectancy was short. Before the 1900, 30% of all deaths, 30%, 1 out of 3 deaths in the world, or in America for sure, were due to infections, pneumonia and the flu, tuberculosis and gastroenteritis, bowel infections, GI infections. Water treatment, food inspections, antibiotics, modern dentistry, and childhood vaccinations. Those 5 things have significantly altered the normal history of human mortality. Those 5 things have resulted in really eliminating these as the primary causes of early death. Top killers today, 28% people die from cardiovascular disease, 22% cancer, 6% stroke, 6% lung disease, 4% Alzheimer's disease. This is going to significantly increase over the next 15 to 20 years. And that's because of the aging population and the boomers. Okay, so that's going to go up. In 1950, 12 million people in America were over age 65. That was 8% of the population. In 2002, 36 million people over the age of 65. That's 12% of the population. In 2030, 71 million people over the age of 65. So you can see the population aging. And then so from 1950 to 2002, 8-fold increase in the very old living over 85. 2020, 7 million people are projected to be over the age of 85 in America. 2040, 14 million people over the age of 85. This is why if you've observed over the last 15 years, one of the greatest industries in America is long-term health care stuff. And these senior retirement home facilities and centers where they have all the bells and whistles and charge you $3,000 to $6,000 a month. Really nice. Love those places, right? But that's all. It's all about preparing to make money off of the retirees as they get older. Aging and disability, over 40 million people over the age of 65 in 2010. 14.5 million of those, which is a little over a third, 36% of them, have some type of disability. 9 million are impaired their ability to walk, that's 23%. 16% could not live independently at 6 million. 6 million have impaired hearing, 3.8 million are cognitively impaired. That's 9.4% are cognitively impaired. And 9% could not provide basic self-care. So it's not, and I put all this up here because I think everybody realizes it, but I stated, it's not simply living longer. We want to live better. Okay? And the good news is we can not only live longer, we can also live better. Both are possible. So what contributes to functional decline as we age? First thing is chronologic age. In this world in which we live right now, the longer you're on the planet, the more hits you're going to take, and it is eventually going to wear you down and you're going to age. Second law of thermodynamics is that if you don't put energy into a system, the system will slowly decay. If you leave your home for 20 years and walk away and don't do anything and come back, it will be not in the same condition as you left. It will have decayed. Allow your car to sit in your yard for 20 years, it will rot and decay. This is entropy. So what about the human genome? There's two theories. One theory is, over the course of time, randomly, with no intelligent input whatsoever, the human genome is randomly improving itself and getting more dynamic and more diverse and having more informed information, and thus we are evolving to higher forms. The other is our genome is slowly decaying over time. And that's what the Bible says, disconnected from God, our genome is slowly degrading. So are we degrading or evolving? What's the science actually show? The science shows, and I won't go through all the different types here, but the science shows that we have at least 1,000 damaging genetic mutations that are new per generation. So you have 1,000 damaging mutations in your DNA that your parents didn't have, 2,000 more than your grandparents, 3,000 more than your great-grandparents, and so forth and so on. And this is happening, and it's well documented in the scientific literature, but the evolutionary community lives in a world of denial, and they want to pretend it's not happening. There has not been one mutation ever identified that adds information to the genome or improves the species. All of them are damaging. Now, natural selection does occur. Natural selection means we select out the worst genetically mutant to not pass on their genes. But just because the ones who survive to pass on their genes are selected to survive doesn't mean they're actually improved from the previous generation. When every member of the gene pool has 1,000 new gene defects, then the survivors are still degraded from the previous generation, even though they've selected out the best of the survivors. Next thing that contributes to aging is oxidative stress. Oxidative stress are oxygen-carrying molecules that damage DNA, protein, and lipids in our body, causing oxidation. So what is oxidation? This is why you hear so much about antioxidants. So what increases oxidative stress? First is obesity. The adipose tissue, when we're obese, produces a reactive oxygen species and interferes with your body's antioxidant enzymes, so it accelerates aging. An obese person at age 70 has 8% less brain mass, and their brain appears 16 years older than a normal weight person at age 70. An overweight person at age 70 has 4% less brain mass, and their brain appears 8 years older than a normal weight person at age 70. Next is tobacco, illegal drugs, and heavy alcohol use. These are very oxidizing substances. They interfere with the body's antioxidant enzymes. They produce lots of free radicals and reactive oxygen species. This is on the left, normal lung fibroblasts, nice, organized, smooth. This is lung fibroblasts exposed to cigarette smoke. This is a woman at 4 years of methamphetamine use. Same woman, 4 years later. Does she look like she's only aged 4 years? No, these are very, very oxidizing substances, and they absolutely accelerate aging. If you see people who have used methamphetamine or cocaine, and you see them a couple years later, they will have significantly aged. You can really see this happen. Chronic stress, activation of your brain's fear circuitry without actually turning it off. So acute stress, where something stresses you, but then you work it out and you calm it down, it doesn't have that consequence. It's the chronic, unremitting worry, anxiety, stress, not able to calm yourself. And this is abuse victims. This is people who live in violent societies or violent places where they're under threat, or belief in fear-inducing God constructs. People who live in, I had a patient in my office just last week, but it's very common for me. And this guy has a chronic anxiety disorder, and he disclosed to me he's been living in fear of going to hell ever since he was a child, and they had sermons on hell. He's never gotten over that fear. And then telomere shortening. I told you we'd talk about telomeres. So what are telomeres? Telomeres are the end caps at the end of your chromosomes. If you remember your mitosis, when one cell wants to divide, it has to copy its library of information. And the library of information are your chromosomes, where all the coded information is, so that both cells now will have a copy of the information. And so it goes through mitosis, it copies them both. The little caps at the end of the chromosome would be analogous to the plastic caps on the end of your shoestrings. And those plastic caps into your shoestrings keep things in an organized way from fraying and breaking down. When your telomere, the little caps at the end, get too short, your cells can no longer divide. And therefore, they can't replace themselves when they get old. And it contributes to aging. Your telomere length at birth, about 8,000 base pairs at birth. At age 35, 3,000 base pairs. At age 65, 1,500 base pairs. If you want to get a functional sense of the difference this makes, think about a 5-year-old and an 85-year-old who both get the same depth of a scratch across their arm. And then you watch the healing on both arms. That 5-year-old, that thing heals like this. They have lots of base pairs. They can make all kinds of replacement cells like this. That 85-year-old struggles because the cells can't replace themselves as well. And then glycation. What is glycation? Glycation is when sugar binds to proteins or other molecules in our body that it's not supposed to bind to. A glucose molecule binds to it, and when it does, the original molecule can't do what it's supposed to do. The glucose can't be used for energy, and the new compounded molecule becomes a molecule that causes oxidative damage in our body. One of the common ones that does this, or you've heard of, is hemoglobin A1C. Have you heard of hemoglobin A1C? Hemoglobin normally carries oxygen in your blood. Glucose is normally used for energy. But now they bind together and you get this new product, hemoglobin A1C. Can't carry oxygen, can't be used, and it is oxidative. And it causes damage. And what condition do they monitor hemoglobin A1C with? Diabetes. And the higher the hemoglobin A1C, the more oxidative stress. That's the more neuropathies, the more retinal damage, the more kidney damage, the more heart disease risk, the more stroke risk. All these things happen because they get more of this molecule, which is oxidizing to the body. So these are called, and by the way, this is called an advanced glycation end product. It's like glycation, an advanced glycation end product, hemoglobin A1C. It's not the only one. It's just the one that most people know about. But there can be other advanced glycation end products, and that same basic process is happening. So they can damage the collagen of the skin. When glucose binds to collagen, you get an advanced glycation end product, and that's what that looks like. That's glycated collagen. It can also bind with oxidized LDL and form plaques in the endothelial arteries. And then when the LDL cholesterol is oxidized, with the glucose, then the HDL cannot remove it anymore. And so that's a graphic of that, but this is what it looks like. This is where the artery lumen should be. All of this is LDL cholesterol that's plugging the artery. It's in the wall of the artery. Now, where do we get advanced glycation end products? Two sources. One is food, browned, fried, charred food. That cooking method, by cooking in that way, causes the formation of advanced glycation end products. And then when you eat that food, whatever the dose is, you will absorb 30% of whatever the total dose is in the food. You'll absorb it into your body. So advanced glycation end products, advanced glycation end products, advanced glycation end products, advanced glycation end products. Okay, and the other is body metabolism. The higher your blood sugar, then your body with high blood sugars will make advanced glycation end products. And this is why diabetics have the higher organ defect problems, damage problems, and cardiac risks. So, and that was really going fast. In the book, it goes through a lot more and gives you much more detail on those. But we're going to talk about pathological aging, Alzheimer's, dementia. So what is dementia first? Dementia is a brain disease characterized by multiple cognitive defects, including memory. You have to have memory problems plus one of these. And that would be a language disturbance, motor disturbance. You can't tie your shoes anymore. Your normal motor movements that were easy, you're having trouble with. It's altered. It's off. Impaired recognition of objects and faces. You don't recognize things anymore. Can you bring that thing people sit in? You can't remember it's a chair. Agnosia, that's agnosia, you can't recognize objects. And then executive function impairment, that's ability to balance your checkbook, organize, plan, strategize, make reasonable decisions. So one of these plus a memory problem is dementia. Just by the way, there are lots of causes of dementia. So there's diseases that damage the brain, And when the brain gets damaged, then you get the syndrome or condition known as dementia. One disease is Alzheimer's disease, we'll talk about in just a moment. So Alzheimer's disease will damage the brain, which results in dementia. But you can have multiple strokes, multi-infarct. Lots of little strokes in the brain. The strokes are now damaging the brain. And when you damage the brain enough with lots of little tiny strokes, then you get memory problems and these other problems, and you get multi-infarct dementia. You can have Parkinson's disease, which can result in Parkinson's dementia. You can have Lewy body disease, which can result in Lewy body dementia. You can have spongiform, mad cow disease, and result in mad cow dementia. So dementia is the syndrome. Multiple disease states can cause the syndrome. Even head injury, TBI, post-concussive dementia. Dementia pugilistica from boxing. Okay, so this is a normal brain. This is an Alzheimer's brain. Don't look at the color. Color is irrelevant. Look at the sizes of the mountains known as gyri and the valleys known as sulci. Notice that over here we got big wide valleys and thin mountains. Well, this is in an enclosed space. So the only way to get bigger valleys is to shrink the mountains. And the mountains are where all your neurons are. So this brain has lost billions of neurons. This is a cross-section of the brain. Here's the healthy brain, and here is an Alzheimer's brain. And notice, these are the ventricles. That's where your cerebral spinal fluid flows through your brain. This is a normal-sized ventricles. Look how big these ventricles are. They only get bigger if your brain is shrinking. That's how they get bigger. Your brain is moving away. It's shriveling up. Now, here's what a healthy neuron would look like. Here is a diseased neuron. And as we come into the axons of neurons, we're going to take this little square here, and we're going to zoom in on that little square. And in the axon of neurons, we have what are called microtubules. And microtubules give neurons structure, strength. They transport neurochemicals from the cell body down to the end plate terminals and so forth and so on. So microtubules are very helpful and necessary for healthy neurons. Now, the microtubules have these special little proteins called tau proteins, and the tau proteins hold them together. Now, here's how you should conceptualize this. Everybody know what a scaffold is? Scaffold, right? And at the corner of scaffolding, you have pins. Anybody ever put a scaffold together? Once you put them together, you put pins in, don't you? And what do the pins do? Hold it together. That's right. What would happen to a scaffold if you pulled a bunch of the pins out? It would collapse. The tau proteins are analogous to the pins. It holds the microtubules together. If something removes or damages your tau proteins, then your microtubules disintegrate. They fall apart. They collapse. And when the microtubules fall apart and collapse, it causes ionic shifts, and the neurons will die. Okay, so remember that. We're gonna, because it's critical to understand the pathological cascade of what's happening in Alzheimer's. There is a gene called ApoE gene. Has anybody heard of ApoE gene? Okay, this is a gene that codes for protein, a lipoprotein that transports fats and fatty vitamins and cholesterol inside the neurons, inside the cells. There are 3 gene variants in the human gene pool, ApoE2, 3, and 4. ApoE2, 7% of the population has that gene. If you have that gene, it increases your risk of atherosclerosis, hardening of the arteries. 79% of the population has the E3 gene. That's a neutral effect. That's the healthy one. It doesn't contribute to any known health problems to have that gene. And 14% of the population has the ApoE4 gene, and this has been associated or implicated in Alzheimer's. If you have 2 copies of the gene, it increases your risk of dementia, Alzheimer's dementia, up to 30 times. 65% of people with Alzheimer's dementia have 1 copy of this gene. But I want to point out, 1/3 of people with Alzheimer's dementia do not have a copy of this gene. What that means is this gene is neither necessary nor by itself sufficient to cause Alzheimer's dementia. A study in Washington University found that people with the E4 gene were not demented if they had a history of exercise. And the reason for that is when you exercise, I mentioned brain-derived neurotrophic factor earlier. It's a protein that makes your neurons strong and branch new connections. That's only one neurotrophin. We know there's multiple neurotrophins. And of the 3 neurotrophins that have been studied most, all 3 of the neurotrophins are turned on by exercise. All 3. And so people who have a history of exercise, and exercise also is anti-inflammatory, which is going to be critical in a moment, reduces inflammation in the body, improves insulin sensitivity, turns on neurotrophins. So exercise is critical to maintaining a healthy brain. Genetics account for about 1/3 of the risk. What's the key? Inflammation, inflammation causes insulin resistance in the brain, and this is likely the key that causes Alzheimer's dementia. So let's talk about amyloid for a minute. When a neuron dies, it leaves behind. When a neuron dies, you have your immune system that comes in and gobbles up and eats up a lot of the proteins and fats and stuff, and gets it. But left behind also are trace chemicals like copper and zinc and iron. And the body has a protein that is designed to grab up those trace chemicals, because those trace chemicals, left alone, are oxidizing and damaging to neurons. So you have a protein called amyloid, which will come in and scavenge up those trace molecules, and normally will then be cleared out of the brain. Amyloid binds and clears them. ApoE is the transporter that removes amyloid. ApoE variants have less amyloid clearance. They do not clear amyloid as well as the APO3 variants. Thus, they get an amyloid buildup in their brain. Now let's talk about insulin. You know, in the body, peripherally, outside the brain, insulin regulates glucose uptake into the cells. Everybody knows that, right? Diabetics don't have insulin, or they're insulin resistant, so we give them insulin oftentimes. Did you know that in the brain makes its own insulin? The insulin in the brain doesn't come from the islet cells in your pancreas. The brain makes its own insulin. And it regulates amyloid clearance. It also regulates tau phosphorylation. Remember what tau is? Tau is your pins that hold your scaffolding together, your microtubules together. Insulin regulates those pins. It impacts blood flow regulation in the brain, inhibits apoptosis, that's cell death. So insulin will actually slow the loss of neurons in the brain, inhibits the inflammatory response, and lipid catabolism, which is catabolism, the digestion of lipids, of fats in the brain. Facilitates neurotransmitter trafficking and synaptic plasticity, the ability to make new connections, and memory formation. Did you know insulin was doing all this in your brain? It's quite profound. Well, here's the similarities between diabetes type 2 and Alzheimer's disease. Both have insulin resistance. You have elevated inflammatory cascades and oxidative stress in both. You have amyloid protein deposits in the brain of Alzheimer's disease and amyloid protein deposits in the pancreas of diabetics. You have tau hyperphosphorylation in both, and you get cognitive decline accelerated in both. Diabetes, if you have diabetes type 2, it increases your risk of Alzheimer's dementia 60%. So insulin resistant in age, 50% of Americans age 45 to 64 have peripheral insulin resistance with normal blood sugar. Insulin resistance, normal blood sugar. You just have higher insulin loads now to keep your sugars normal. 50% of Americans at that age. 76% of Americans over 65 have peripheral insulin resistance. Triggers of insulin resistance. What triggers or causes insulin resistance? High fructose diet, high fructose corn syrup, high-fat diet, chronic inflammation and stress. So what's happening? Beta amyloid, interleukin-6, by the way, is an inflammatory cytokine that comes from chronic stress and upregulating the inflammatory cascade. Tumor necrosis factor alpha is also an inflammatory cytokine. Chronic stress increases inflammatory cytokines. So one of these three will cause the insulin subreceptor in the neurons to become phosphorylated, and that then renders it less responsive to insulin. And this is strongly associated. So insulin resistance in the brain, just like insulin resistance in the body, less responsive, and therefore don't take up glucose as well. Insulin resistance in the brain, less responsive to insulin in the brain. And so inflammation, insulin resistance, phosphorylation of the insulin subreceptor, amyloid is not being cleared out of the brain. Amyloid's building up now because that circuitry or that pathway that would clear it is resistant to insulin now because we have inflammation going on. The amyloid not being cleared builds up, and amyloid will cause phosphorylation of tau if it builds up. Tau is your pins in your scaffolding, right? Once you phosphorylate tau, it can no longer do its job, so if tau comes off and your microtubules begin to disintegrate. When the microtubules disconnect and disintegrate, you get the ion flux in and you get cell death, and when the cells leave behind trace chemicals like iron, copper, and zinc, and the body and the brain sends in amyloid to scavenge up the trace chemicals, but you're insulin resistant, so you can't clear the amyloid, so more amyloid is building up, which is phosphorylating more tau, which is causing more microtubules to disconnect, which is causing ions, which is causing cell death, which is causing, and you see where we're going with this. Okay, this is what's happening. Another potential pathway, though, is a head injury or the bad genes, which both can cause amyloid buildup, insulin resistance, phosphorylation by amyloid, tau phosphorylation, and the same cascade can happen from this way. So anything that increases inflammation will increase your risk of late life Alzheimer's dementia. Obesity, it's a very complex problem. Sleep deprivation alters body hormones, impacts metabolism, alters our energy burn and reserves, and increases the risk for obesity. So chronic sleep deprivation. According to the CDC, 50 to 70 million Americans have some type of sleep disorder. 2009 multi-state CDC survey found that 70,000 adults, found that 35% slept less than 7 hours a night. And that's the American way. And this is a factor in obesity. Soybeans. Did you know soybeans are a factor? Historically, the human diet had 1% linoleic acid. This is a fat. This we're talking about soybean oil, not soybean protein. Okay, soybean oil. Okay, linoleic acid is part of the oil. Over the past 100 years, U.S. has increased from 1% to 8% linoleic acid, primarily from soybean oil. And the soybean oil is in lots of stuff, just like high fructose corn syrup. You look on the labels of lots of stuff. Soybean oil is the primary oil used for most food manufacturers. Linoleic acid is a precursor to two marijuana-like compounds in the brain called cannabinoids, endocannabinoids, and they increase your appetite, reduce satiety, and thus cause you to eat more and increase your risk of obesity. Animals-fed diets composed of 35% fat and 8% linoleic acid had significantly greater obesity than animals with a 60% fat diet and only 1% linoleic acid. And then when animals adding omega-3 fatty acids from fish oil with EPA and DHA to the 8% diet reversed the elevation of the endocannabinoids and decreased food consumption and obesity. Omega-3 fatty acids primarily from fish oil. Insulin levels were not altered in either group, indicating that this was not due to a reduction in carb intake, which some might argue, what's a high-fat diet? It's Atkins diet, reducing carbs, that's what's happened. Insulin levels were not changed. So it wasn't really that. Obesity and gut bacteria. Older people have less bacteroides. Obese people have less bacteroides and more firmicutes than lean people do. So the gut bacteria, and it affects how much energy is taken out of the food. Diets that result in weight loss also result in increasing bacteroides and decreasing the firmicutes. Food choices will change your gut bacteria as quickly as one day. You alter your diet, your gut bacteria will shift in a day. Plant-based diets increase the growth of the good bacteria. Animal-based diets increase the opposite bacteria. Obesity is not only causes inflammation, but inflammation causes insulin resistance, which drives obesity, so it becomes reinforcing. 4 keys to preventing Alzheimer's dementia: physical conditioning, exercise, regular exercise, increases insulin sensitivity, activates all the neurotrophins, reduces inflammation. Active animals have larger hippocampi, that's where new memories take place, than non-active animals. Older people who walked regularly, as little as 15 minutes per day, have lower risk for Alzheimer's dementia than people who don't walk daily. People who routinely exercise exhibit better cognitive abilities and have larger brain volumes. And exercise in older adults saw a 2% growth in the hippocampi, where new memories take place. They could measure on scans, 2% growth, which reversed 2 years of aging. Mental conditioning, reading, writing, crossword puzzles, Bible study, new learning, taking a college class, something that causes you to cognitively stimulate yourself also helps reduce risks of dementia. Stress management, chronic stress activates the inflammatory cascade, so reducing stress is helpful. A study of 5,000 individuals found that neuroticism including feelings of guilt, anger, anxiety, and depression, was associated with greater risk of dementia, but conscientiousness was not. It was protective. There's a difference between neuroticism, which is irrational guilt and fear and worry, versus a conscientious person who makes choices live in harmony with their conscience so they don't feel guilt and shame and worry. Overactive amygdala activates the sympathetic nervous system, which activates macrophages because the immune system is to your body what the National Guard is to our nation. It protects us from invasion. So under stress, you're saying to your body potential invasion, gear up for a potential microscopic invaders. So we turn on our immune system, which releases inflammatory cytokines if it's under chronic state, and they are damaging insulin receptors, as I've mentioned before, which interfere with all kinds of processes, increasing the diabetes, obesity, high cholesterol, heart attacks, strokes, all of which are increasing risk of dementia. God construct, I mentioned in the last one, so I'm going to skip it. Same data. Same there, the altruism. Let's talk about sleep. Obstructive sleep apnea impairs mood and contributes to cognitive decline. In fact, people with untreated obstructive sleep apnea had loss of gray matter, but it was reversed with treatment. With a CPAP machine, it reversed. The gray matter came back. Sleep disorders double the risk of depression. Now, during sleep, I want you to understand why sleep is so important. You remember, your brain is highly metabolic. It uses 20% of your body's energy. So burning up all that energy means there's byproducts of metabolism. Byproducts of metabolism are oxidizing. Your body needs to clear them. So during sleep, your neurons actually contract and expel the byproducts out of the neurons into the cerebral spinal fluid, where it will be cleared out of your brain. But if you don't get normal sleep, you don't clear all these byproducts of metabolism. And if you do this chronically, then over the course of time, you build up oxidative metabolic products in your brain that increase your oxidative stress and increase your risk of dementia. So, Sabbath rest. You all familiar with Dan Buttner's book, The Blue Zones? Okay, the 5 places in the world where people have the highest concentration of people living to be over the 100 years of age. You'll notice only one in America, Loma Linda, California. And all the first 4, these are a very homogeneous group of people. Loma Linda is heterogeneous, meaning from all different cultural backgrounds or genetic backgrounds. But as you know, it's high concentration of Seventh-day Adventists. And from the Blue Zones website, find a sanctuary and time to decompress. Observe the Sabbath from Friday to Saturday night is how the Adventists do it. And they felt that this was a factor into why Adventists lived so long. It was a weekly time to decompress, relax, and break the stress cycle. But Seventh-day Adventists, to be fair, also eat more healthy than the average people. Higher percentage of vegetarians. They don't smoke, use alcohol, use illegal drugs, exercise more than most, and have less obesity. So let's be fair that these factors were involved too. And then nutrition. Normal weight, Mediterranean diet, or a whole food vegan diet, avoid sugars and trans fats. Those are the big keys, but let's go through some now nutritional factors. Vitamin D in dementia. A study of 1,658 people over the age of 65 with no dementia at the outset, had vitamin D levels measured, and then again 5.5 years later. 171 of those had developed some form of dementia. 102 of those were Alzheimer's dementia. And what is the increased risk of dementia? Well, if the vitamin D level was less than 25 nanomoles per liter, it increased the risk of dementia 2.25 times. All-cause dementia went up 2.2 times for Alzheimer's dementia. So it was doubling the risk if you had a low vitamin D, doubled your risk of dementia. If you had a vitamin D between 25 and 50, then it was 1.5 times the risk of dementia. And then recommended levels really 75 to 100. If you actually go over 125 on your vitamin D levels, it increases the all-cause mortality. And levels below 25 increase all-cause mortality, not just dementia. So super low levels and super high levels are very unhealthy. Curcumin, yellow Indian spice from turmeric, binds amyloid protein directly and helps clear it out of the brain. It keeps it soluble so it doesn't become insoluble in your brain. Has an anti-inflammatory effect. Binds to iron and copper, so it can help remove those oxidizing trace chemicals out of the brain. Free radical scavenger. It does not benefit people who already have dementia. Its benefits are in prevention of ever getting dementia. And that makes sense because those brains already lost billions of neurons. It's not going to replace those neurons. But you only absorb it if you take it in conjunction with black pepper. Seriously, black pepper increases its absorption 8,000 times. Without black pepper, you barely absorb any of it. So you can just waste your time taking this if you're not having black pepper with it. Yes, so you need the black pepper in order to absorb it. Walnuts, adults who regularly eat walnuts have better cognitive performance. Walnut extract prevents amyloid fibrillation. Again, the amyloid stays soluble so it can be removed from your brain. Walnut extract also dissolved amyloid plaques in lab studies. So I recommend eat a handful of walnuts a day. No harm. Green tea, rich in antioxidants and flavonoids, improves cognition and memory in all groups. Those without dementia, those with mild cognitive impairment, those with advanced dementia. All groups showed improvement with green tea. It actually, it is antioxidant that clears amyloids. And what they measured is when they look at neural circuitry pathways, green tea caused improved firing from prefrontal cortex to other parts of the brain, so it helped connectivity of the brain work better. In addition to reducing oxidative stress on the brain and having protective effects. Pomegranate juice, high concentration of antioxidant polyphenols, pretty much higher than any other juice. In animal studies, it removes amyloid out of the brain. And Vanderbilt research found those who drank juice 3 times per week or more were 76% less likely to develop dementia than those who drank 1 glass or less per week. When I'm at home, I drink an 8-ounce glass of pomegranate juice, 100% juice, every day. I eat a handful of walnuts and pecans every day. This benefit was even more pronounced for those who had the high-risk ApoE4 gene. So those with the high-risk gene had even a better response to the pomegranate juice. The benefit was from the polyphenols, not from vitamins in the juice. They actually looked at that. So drink 8 ounces of 100% pomegranate juice a day. Coffee. A New England Journal of Medicine research of 50,000 people followed for 13 years after adjusting for various risk factors found that regular coffee consumption reduced all-cause mortality. You live longer if you drink coffee. Multiple studies show that coffee consumption reduces the risk of cardiovascular disease, strokes, cancers, type 2 diabetes, Parkinson's disease, and Alzheimer's disease, all reduced with regular coffee consumption. Coffee has antioxidants that prevent LDL from oxidizing and thus building up in the arteries, and amyloid from building up in the brain. Moderate daily coffee drinkers reduced Alzheimer's disease risk by 65%. Caffeinated coffee increases anti-inflammatory cytokines and clears amyloid. Caffeinated coffee. Caffeinated coffee was beneficial in all the studies. Decaffeinated coffee was not. Caffeine alone has no benefit. And caffeine in any other beverage other than green tea is no benefit. And the researchers believe that it's the combination of the caffeine and the antioxidant molecules in the coffee together that provide the benefits. Now, there are cautions with coffee. Coffee should really be considered more of a medicinal than, say, the walnuts or the pomegranate juice. There's really no real risk or downside to those. But there's a risk with coffee, several risks. You need to be aware of them, just like you would a medicinal. First off, artificial sweeteners increase depression and dementia across the board. Don't use any artificial sweeteners ever. Get rid of them all. Sugar in the coffee and honey in the coffee did not increase the risk. So high sugar diet will, but these are people who are really maybe just putting a little teaspoon of sugar in their coffee, but they're not having a high sugar diet. That little bit of sugar did not increase the risk. But coffee lowers the seizure threshold, makes it more easy to have a seizure. So people with seizure disorder need to be aware of that fact, especially if their seizures are poorly controlled. It may not be a good idea. It also can impair sleep, and sleep the requirements for life, and if you have sleep disorder and not getting 7 to 8 hours of sleep a night, that increases your risk of dementia. So there are some people who can drink a couple of cups of coffee a day and still sleep well at night. There are other people who really can't. they are really impaired in their sleep with some coffee. They should not drink the coffee. Sleep is more important than the benefits of some antioxidants in coffee. You get antioxidants, other stuff. And the third is a vasoconstrictor. Caffeine's a vasoconstrictor, and people with certain disorders that have vascular disease, like coronary artery disease, macular degeneration, Raynaud's disease, etc., you should probably avoid the caffeine because it'll make those diseases potentially worse. Vitamin E and vitamin C, they're antioxidants. Vitamin E is very helpful from food, lowers the Alzheimer's disease risk. It's harmful from supplements. And I'm not going to go through the detail. In the book, I go through the details. But there's research. Oh, this research, vitamin D helps. This research, vitamin D harms. This research, vitamin D helps. This research, vitamin D harms. If you break it down, the vitamin D from supplements harms. The vitamin D from food helps. And nature of vitamin E, vitamin E has 8 isomers. When you get it from food, you get all 8 isomers. When you get it from supplements, you get primarily 1 or 2 of the isomers. And it causes a problem. So almonds are high in vitamin E. Vitamin C is helpful from food or supplements. So really, vitamin C, you can get it from either source, and it's fine. And vitamin C, by the way, so vitamin E is a lipid, which will concentrate in the fatty membranes of your neurons and be free radical scavenger, protecting from oxidative molecules that try to damage your neuron. That's what vitamin E does. Vitamin C is soluble in water, and thus it's in the cytoplasm inside the neuron, so anything that makes it through the lipid membrane, vitamin C will scavenge up in this antioxidant, and vitamin C will then reactivate vitamin E that has already been used to scavenge up some free radical. Vitamin C will help reactivate it and put it back out. So they work together. N-acetylcysteine, this is a mitochondrial membrane stabilizer. It's an antioxidant free radical scavenger, reduces oxidative stress on the brain. Animal models, NAC improves memory and learning. You can't get this in a food source. Just take a supplement if you want to take it. I take 1,500 milligrams of N-acetylcysteine every day. B12 and folic acid, which is B9, required for lots of metabolic processes, blood, DNA, neurotransmitters, neuronal health, cell reproduction, lots of things. It also, a byproduct of metabolism is called homocysteine. These 2 vitamins are required for your body to clear homocysteine. If you don't have enough of these, then homocysteine builds up, and homocysteine is very oxidizing and damages endothelial linings and damages neurons, increases your risk of dementia. And there is a gene defect in the human genome called the MTHFR gene, and that's the gene that metabolizes folic acid from food into the methylated form, and only the methylated form can get inside your brain. The unmetabolized form that we get in food can't get in your brain. 50 to 60% of people with depression have this gene defect. And so their brains don't have the folic acid they need, which is important to make for neuronal health and neurotransmitter production, as well as removing the homocysteine. So supplements of methylated B12 and folic acid reduce dementia risk. Hormone replacement therapy. If you've heard about hormone replacement therapy for women, study it's helpful, study it's not helpful. A lot of conflicting data out there. Should I take it, should I not take it? And no benefit is benefit. The key they've discovered, it's the timing in the perimenopause and postmenopausal period of when the hormone replacement therapy has started. If estrogen is started within 5 years of menopause, then you have reduced heart disease risk and reduced Alzheimer's disease risk. If it started later than 5 years, it has no benefit. So it's in the first 5 years of menopause. If you start it and keep it, you actually reduce your Alzheimer's disease risk. Study of 8,000 women followed for 20 years found that hormone replacement therapy decreased Alzheimer's dementia by 40 to 50% if started within 5 years of menopause. Later, no benefit. So prevention options for dementia: healthy diet, eliminate simple carbs, red meat, highly processed foods, fried foods. I didn't talk about fasting. There's a whole section of fasting in the book and a whole bunch of other stuff. So fast 12 hours, at least 12 hours between dinner and breakfast. That's why breakfast is called breakfast. It's break fast. You're breaking your fast. Okay? And so 12 hours, and if you do that, that actually has a lot of benefits, reducing oxidative stress on your body, lengthens life, and lengthens telomeres, lots of good things. Almonds, walnuts, vitamin C, vitamin D, L-methylfolate and B12, N-acetylcysteine. I didn't talk about the berries. I didn't have time to do all the nutritional stuff, but berries, all the berries are very antioxidant, very good for you. Omega-3 fatty acids from fish oils. Let's talk about that briefly. A lot of people may take flaxseed. Flaxseed is ALA, short-chain omega-3 fatty acids. ALA, short-chain omega-3 fatty acids are not useful to your brain. They don't have benefit to your brain. Your body can convert only about 1% or less of ALA into the form the brain needs. The brain needs ALA and DHA. If you're a real strict vegan, then you can go to some nutritional stores and they have some algae sources of the DHA EPA, or you can just get it from the fish oil sources, whichever you want. But your brain needs DHA EPA. 70% of the fat in the brain, which constructs the neural membranes, is DHA EPA omega-3 fats. They're free radical scavengers. They enhance neural fluidity. It's also a factor in postpartum depression because when a woman's pregnant, she's giving up her omega-3s to form a fetal brain unless she's reducing her own, and she has higher risks of depression afterwards. That's why most prenatal vitamins now have omega-3s in them. And kids with higher omega-3s, they have higher IQs and they score better and have less mental health problems than kids with low omega-3s. So omega-3s are really good for brain health. Exercise 15 to 20 minutes minimum daily. Pomegranate juice, sleep stabilization, mental activity, Bible study, puzzles, new learning, healthy spirituality, meditate on the God of love, consider hormone replacement therapy. Talk with your doctor about that. Now we can do question and answers from anything from the weekend.